See, isn't this just like crazy graph week here at Putnam Valley? So we made piecewise function graphs, absolute value graphs. And holy cow, look at these wild looking graphs. Yeah, these are graphs that we call root functions. So when I say root, you might think like square root, and there's other root functions too. We're going to play with those. So the first one we're going to start with is graphing this one on your graphing calculator. It's the square root function. So go ahead, take a minute, graph it on your calculator. All right, so when you do that, the square root of x, and you press enter, it seems like we got the right half of the graph. Where's the left half? Well, check out the table for a minute. If I go Command T and show you a table. So first of all, what you notice is that when x is 0, we get 0. And see the decimals here? So if I'm making a table of values, I don't know if I'm really going to include those decimal values. I'm not really concerned about the x value being 2 or 3, but 4, 2 is a good point to plot. And there's going to be another one coming up, I think. 9, 3, yeah. But the fun begins when we get back behind 0. Oh no, look down here. Go tweet it out. Hashtag error. Why the heck are we getting hashtag error? Well, think about it. If you take the square root of a negative number, it doesn't exist. It's what we call an imaginary number. So yeah, that hashtag error means don't plot those points either. The graph just stops. So let's go back, Control T, go to a table maybe. Go over here, let's plot some of these points, right? So 0 was a good one to plot. 1 was a good one to plot. 2, no. 3, no. 4, yeah. 5, 6, 7, 8, no. 9, yeah. 3. So we start at 0, 0. There's like a closed dot at 0, 0 because the graph doesn't go anywhere to the left of that. And then it goes through 1, 1, 4, 2, 9, 3. Hey, it kind of looks like a sideways parabola. It does. It is, because the inverse of squaring is square rooting. Oh, you are a genius. No, you just do your math homework. Good for you. Yay. Fantastic. So that's a great square root function. And guess what? You know those transformations? They still apply. Just like the transformations to the x squared, just like the transformations to the absolute value, these transformations still work too. So when you look at this, think about, tell me what some of these transformations are doing. Remember that the negative flips the graph over. Remember that the 3 means move it to the right 3. And that the plus 2 means it goes up 2. So that point 0, 0, which was kind of like our vertex, the next new point on our graph is going to be that point 3, 2. So maybe if we make a nice sketch of it, we're going to go to the point 3, 2, and we're going to flip the graph. So it's going to kind of go something like that. Take a minute, check it on your calculator. Does it look kind of like that? Take a peek. So keep moving now, my friends. Another function. We call this a cube root function. And just like the inverse of squaring is square rooting, the inverse of cubing a number, or that cubic graph, is a cube root graph. Can you find it on the calculator? Remember to go to that math template, right? Let's see, I'm going to do a little Control N on mine. I'll get a new graph. Let's add a graph. Boom. Go to that math template right there. We had piecewise before. Let's go over now and choose the cube root. And I actually think we could do it there, or, let me press escape. Look what's right above the caret button. See where the x squared is? It's this button over here. I'm going to circle it in red. I think if you go Control that button, yeah, we get it there. So we could do the cube root of, I pressed the wrong button. I got to get down to there. There we go, press X. So the cube root of x. Check this graph out. Oh, wait, doesn't it look like that cubic graph flipped over sideways? Yeah, oh, wait till you get to Algebra 2 and Mr. Baker's going to talk to you about inverse functions. Oh, you're going to love it. I can't wait. Please remember me on that day. So yeah, this is a pretty neat graph. And if we go to a table of values, Can you tell that this graph is a continuous graph? It's not like the last one. So we are going to get a bunch of negative values in our table. And again, just keep the decimal ones. And what you're going to notice is like -8, -2. There's a cube root of 8. So the big cube roots to take are like 8 and 1. So those are the ones we want to graph on our screen. So on our table for the x and the functions, we'll take like -8, -2, -1, -1, 0, 0, 1, 1, 2, 8. Oh, not 2, 8. Going cube root. So 8, 2. So plotting some of those points, we got -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. And again, connect them in a nice, smooth kind of curve. Quick question. Can we transform these graphs too? Yeah, you can. Funny you ask. Oh my goodness. Can you tell the transformations being done to this graph? So what's happening here? We're going from that x minus 1 underneath is telling me that it's going to go to the right 1, and it's going to go up 4. Cool. So the point 0, 0, instead it's going to move to the point 1, 4. So a sketch of it, go to the right 1, up 4. So maybe now it comes like this way and then goes up and then goes that way. Now, I do want to talk about using this interval from -7 to 9 for a second as well. So when we go to our table of values on the calculator, we want our minimum to be -7 and our maximum to be 9. Those are the only values we want. So let's go to the calculator real quick. And what I'm going to do is I'm going to go Control T, get out of that table, and I'm just going to edit that equation. I'm going to press Tab, and I'm going to go back up here. And I'm going to make it the cube root of x minus 1, get out of cube root land, plus 4. Okay, quick look. Does that equation look like the one that I want to graph? Yes, it does. The radical stops at the 1. Press Enter. Boom. See how I just kind of moved it up and over a little bit? So now, how does that -7 to 9 come in? So when you go to your table, the only values that you want in your table are when x is -7 up to when x is 9. So at -7, we're at 2. Then we're going to go 3, 4, 5, and then at 9, I bet we're going to be up at 6. Yep. So let's go back to let's make a little table here. And the values that we liked -7. What other ones did we like? I think we liked 0, 1, and 2, and then 9. Those are typically like you get 5 values for these. So we said -7, we were at 2, then 3, then 4, then 5, then 6. So if we were asked to specifically graph this one, we could plot those points off in our table. Oh, but one last thing. Because we're kind of told there's a specific interval for the graph, notice that we're not going to include any x's that are less than -7 or greater than 9. So in this one, we're going to be a little finicky. We're not going to put arrows on the end of it. What'd you say? No arrows on the end of it, because you're given an interval of values. We just put endpoints on it, and that's what our graph is looking like. So this is some stuff you can definitely do with your calculator. It's a lot of fun. I enjoy doing these graphs.